So we did chapter 2 of AP Physics 1. We are now doing chapter 3. AP Physics 1. So first we will do study about vectors. So as in the last chapter, we did we studied about velocity, and velocity, it is any quantity such as velocity. It has a direction, it has magnitude as well as direction. So the quantities which have both magnitude and direction, they are known as vectors. Okay, vectors have magnitude as well as the direction. Vector quantities have magnitude and direction both. And it is given by a capital letter with an arrow on its head. And there are other quantities such as quantities which are known as scalars. They have magnitude only. Okay. So the examples of vectors are the quantities, like other quantities that are vectors are displacement and force, momentum, velocity. These are the examples of vector quantities. They have the direction as well as the magnitude as well as the direction. And the scalar quantities are the quantities which have magnitude only. The example is like mass, temperature, time, and money, distance, and speed. And scalars, they can be negative, like temperature can be negative, money, okay? But that's not because of the direction, their value, okay? So scalars can be negative, okay? And we use the boldface to write when we write a symbol for the vector, we use a boldface with a tiny arrow over the symbol. Okay. Now, if there are two vectors and we have to add them graphically, so suppose this is a displacement vector d1, okay. And when we say that a car travels 8 kilometer east, okay, and then it travels 8 kilometer west or 8 kilometer west, okay. So the resultant would be, it started from origin 8 kilometer east, okay, this is D1, okay, and then it traveled 8 kilometer west, okay, this is D2. So the resultant vector would be 8 minus 8, 0, okay. And suppose we say that a car travels 8 kilometer east and then travels 8 kilometer east again, like this. First it travels 8 kilometers. Okay. And then again it travels 8 kilometers. Okay. These are the two vectors d1, d2. So dr will be d1 plus d2. It is equal to 8 plus 8, so 16 kilometers. So the direction would be 16 kilometers east. Okay. So these are how we add the vectors, but when they are in the straight line. Okay. But simple arithmetic we cannot use when we are adding the vectors which are not in a straight line. Okay. So suppose this is a vector d1. Okay. And it is and this is vector d2. So suppose if we have to add this, what we do is we draw a vector parallel to d1 of the same length. Okay. And then we add vector tip of the vector d2 to the tail of the vector d2 to the tip of vector d1. Okay. In the same direction and the same length. Now the resultant would be from the tail of the d1 to the tip of the vector d2. We draw a vector from the tail of the d1 to the tip of vector d2. This will give us dr, or the resultant vector. So this would be dr, or the resultant displacement in this case would be d1 plus d2. So this method is known as tail to tip method. Tail to tip, this is a vector equation, and this method is known as tail to tip method of adding vectors, where we draw a first vector parallel to the given vector and add the second vector, add the tail of the second vector to the tip of first vector. And the resultant vector is from the tail of the first vector to the tip of the second vector. And this method is known as tail to tip method of adding vectors. Okay. So, and these vectors, the resultant is not affected by the order in which vectors are added. Okay. So vector d1 plus d2 is same as vector d2 plus d1. So this is, suppose if we add vector d2 first and then add the vector d1, the tail of d1 to the tip of d2. Now the resultant vector would be from will be the vector from tail of D2 to the tip of D1. This is known as the resultant vector. Okay. So the order, the resultant is not affected by the order in which the vectors are added. This is also known as the commutative property of factor addition. We can also use tail to tip method for adding 3 or more vectors. Okay. Suppose this is a vector D1. Okay. This is vector D2 and this is vector D3. So we can draw a vector parallel to D1 D2 and D3. So this we can make it little. This we can make it a smaller. So this would be, if I make it little smaller, D3. So now from the tail of D1, if we draw a vector from the tail of the D1 to the tip of D3, that will give you the resultant dr. Okay. So the tail to tip method, this is the tail to tip method of adding vectors of more than 3 vectors. They can still be added. And we can also use another method of adding 2 vectors, which is known as the parallelogram method. So in this way, what we can do is, there are 2 vectors, suppose D1, and there is another vector D2. So we draw a vector parallel to D1 and we draw another vector D2, a vector parallel to vector D2 from the same common point, from the tail of V1. So here in this method, 2 vectors are drawn starting from the common origin. Okay. So we draw vector D2, which is the same direction as D2 and same length. We draw it from the common point. Okay. So this will be, now we complete the parallelogram. Okay. So the resultant is the diagonal drawn from the common origin. the resultant is a diagonal drawn from the common origin. And this method is known as the parallelogram method. Okay. So in this case, the resultant vector is the diagonal drawn from the common origin where the two vectors are added. But if we draw the other diagonal, doesn't give us the resultant vector. Other diagonal, this doesn't give us the resultant vector. Okay. So this is the parallelogram method. So suppose we have two vectors. Vector A is 5 units and vector B is 5 units. Then what is the maximum or what is the range of possible lengths of the vector which gives the sum of the two vectors? If we add them, what is the range of possible lengths? So see, if they are in the different direction or opposite direction, it will be like, if they are in the opposite direction, it will be 5 minus 5, 0. Like if A is pointing east and B is pointing west, so it will be 0. If both are pointing towards same direction, then it will be 5 plus 5, which is equal to 10. This is vector A and this is vector B. 5 plus 5. So it will be 10. And if they make an angle, which will be between 0 to 180, so definitely its value will be less than 10. So the values, they range from 0. Values of the sum of the two vectors, they range between 0 to 10. Now, if we want to do this mathematical way of adding the vectors, what we would do, and no vector is ever negative, magnitude is always positive. Okay. Now, if we want to subtract a vector, then we have to just reverse the direction. Okay. Subtraction of a vector. If we have to subtract a vector from the other vector, we would just reverse the direction, and then it would give us the resultant vector would give us the subtraction means. It would. So in this case, it is like, if it is, so this is a vector V. Okay. So this would be vector negative V. So it would be the negative of the vector V would be the same vector with the same magnitude but in the opposite direction. So the minus sign tells us about its direction. No vector is ever negative in considering its magnitude. Okay. So if we have there are two vectors. Suppose this is a vector D2 and this is vector D1. Okay, so and we have to subtract. So what we will do, we'll keep the D2 as it is and we will reverse the direction of D1 and the same length. So this would be D1 negative D1. So now if we draw the vectors parallel, so we can start with vector D2, draw a vector parallel to D2. Okay. And draw a vector parallel to D1 and the resultant vector which is from the tail of D2 to the tip of D1, that gives you the resultant vector. So the difference between the two vectors is equal to the sum of first minus negative sum of the first plus the negative of the second. So here dr will be given by dr will be d2 vector minus d1 vector. Okay. So we draw it in the opposite direction and add it and the resultant vector is drawn from the tail of the first vector to the tip of the second vector. Okay. Now we can add the vectors using components also. But first let us see the 8 ways of adding vectors. 8 ways to describe the direction of the angle. Okay. So these are the 8 ways. Of describing the direction of an angle. So this is east. Okay. This is north. This is west and south. So suppose this is 30 degree. So we say this is 30 degree north of east. And this is 60 degree. So we say 60 degree east of north. Same way this we say it's west of north. Okay. And this we say it is north of west because this angle is this much, whatever it is, suppose it is 40 degree. So we say it is 40 degree north of west. Okay. So this thing is south of west and this is west of south. And this is east of south, and this is south of east. Okay. So this we'll use while doing some problems, which we are going to do now. So suppose now what we'll do is suppose there is displacement of 80 centimeter north of east. Okay, this is the displacement. So we can, okay, so this is a vector D, okay, which is 80 centimeter north of east. So a vector is sum of the two other vectors which are known as components of the original vector. So the components are chosen to be the two perpendicular directions like x and y. So every vector like D, it has two components like dx and dy. Okay, sorry, dx and dy. Okay, so the process of finding the components is known as the resolving the vector into its components. So suppose this is 80 centimeter north of east, and now we have to resolve this vector into its component. So we draw a vector D, and it is 32 degree north of east. Okay, so this will be north of east means this is 32 degree. Okay, so if we this will be dx and this is dy. Now we know sine theta is equal to dy over d, and cos theta is equal to dx over d. So this will be d sine theta will be 80 sine 32, which will be around 42.3. Okay, and cos theta, so dx would be d cos theta 80 cos 32 degree. So this is around 67.8. Okay. So we have resolved the vector into two components. One dx is equal to 67.8 centimeters and dy is equal to 42.3 centimeters. Okay. Now, if the components are given, then also we can get the final vector, and that is final vector d. It is equal to the square root, the square of the components, dy dx. This is the d, and this is dx, and this is dy, and this is theta. So if we put both the values, this will be 67.8 plus 42.3. Okay. So this will be given as 79.75. So it is close to 80 with which we started. Okay. And tangent theta is dy over dx, which is given by 42.3 to 67.8.62, and theta is equal to tangent inverse 0.62. So this is known as, this we get is 39 and 6. So close to 32 degrees. Okay. So we were given a vector 80 centimeter and 32 degree north of east, and we found we resolved it into two components, dx and dy, which came out to be 67.8 and 42.3. Now using this, we again got our vector, which was came out to be 79.95 or 80, and the angle we got is dy by dx, which came out to be 32 degree. Okay, so this is the process of finding the components, is known as resolving the vector into the components. Okay, we can it, we can also find the resultant vector using its component. So suppose this is a vector v1, okay, and vector v2, okay, and we have to find its resultant vector using components. So what we can do is we can draw a vector parallel to v1 here. Okay, find its x component and find its y component. Then we add vector tail of the vector v2 to the tip of vector v1. So vector v2 x and v2 y. Now the resultant vector, as we know, it can be found out by uh, adding the vector from the tail of v1 to the tip of v2 gives us the resultant vector, and that is equal to v1 plus v2. So if we, this will be vr x component of the resultant vector and y component of the resultant vector. So vr, the resultant vector, is the vector sum of vector v1 and v2, and x component of the resultant vector is equal to x component of the first vector plus the x component of second vector, and y component of the resultant vector will be equal to y component of the first vector and the y component of the second vector. The components of the given vector depends on the choice of coordinate axis. We can do one more problem regarding this. So suppose if a car travels 100 meters east and then turns 35 degrees north of east and uh, travels 50 meters and then turns and travels 50 meters north. So what is the total? So what's the total displacement? So vector A is like 100 meters. Okay. It travels okay 100 meters and then 50 meters 35 50 meters north of east. Okay, this is 50 meters. This is vector B. and C is 50 meters north. So now we have to find the resultant. So resultant will be from the tail of the A vector to the tip of the C vector. So first tail A vector is towards east, so we don't need to find its component. For vector B, which is making 35 degree, so we find the component Bx and By. Okay, so that would be Bx would be B cos theta, which would be 50 cos 35 degree, and that would be 40.95. And By would be B sine theta would be 5. Oh, this is 50. It's 50 sine 35 degree. So that would be 28.6. Okay. So the resultant would be, we'll add the x components. So x component is 100 plus 40.95. Okay. So resultant is like x components square plus y component square and square root of it. So it would be add x components will be 100 plus 40.95. Okay. And we do not round up in between. We can round up our answers in the end, but we do not round up while doing the questions because it may give the wrong answers. And then we'll do 50 plus 28.6 square. So this gives 161.3 meters. Okay. And to find the angle, we can find the angle here. It would be tangent theta, and the y component is 50 plus 28. Basically, it is By plus C, and which is 50 plus 28.6, and Bx will be 100, so it will be A plus Bx. So it will be 100 plus 40.95. So if we find the angles, finding its inverse, it would be 29.14 north of east. So it is 29.14 north of east. 29.14 north of east. So, so this is how we find when the vectors are the like vector A, and vector A was the horizontal component, it did not have any vertical component. Vector C did not have any horizontal component, it had only vertical component. And B was at an angle 35. So we found two components of B, horizontal and vertical. And then we found the resultant vector using this formula, and we found the angle. Okay. So this is the magnitude of the resultant vector, and this is the angle of the resultant vector. We can also try doing one more problem regarding this. So, suppose a car goes 70 meters west and then turn north and drives and then drives 50 meters. Okay, so first car goes 70 meters west, then turns north and then drives 50 meters, and car then turns and travels 40 meters southwest. Okay, so what is the total displacement? The car goes 70 meters west and then turns north and drives 50 meters. Okay, so first is 70 meters west, okay, and 50 meters north. And then, so this is vector A, okay, this is vector B, and then 40 meters southwest. So we see that vector A is horizontal. It doesn't have any vertical component. Vector B doesn't have any horizontal component. It has vertical component. So vector C is like which we have to find find its component. Okay. So vector C is like this, which is 40, and southwest means this is makes 45 degree. Okay. So this is 45 degree. This is CX and this is CY. So this is C. C is equal to so this will be minus 40 sine 45 degree because it is moving towards left. Okay. So this comes out to be negative 28.28 degree. Okay. And Cx will be C cos 20 cos theta, which will be minus 40 sine minus 40 cos 45 degree. Okay. So this comes out to be negative 28.8. Okay. Now we can add, to find the resultant, we can add all the y components and all the x components. We can also draw a figure like this. This is C. This is CX. This is CY. Okay. So this gives us the resultant x component. This is the, I'll draw with the green color, a different color. So this is the resultant. This green color is the resultant vector, which is drawn from the tail of the A vector to the tip of the C vector. So resultant vector, so Rx here would be negative 70 because it was towards west, and negative 28.8, which gives us negative 98.28. And Ry would be 50. It's positive because it's moving towards north, and the Cy is negative because it is pointing towards down, so it is 28.8. So this will give us 21.7. So now the resultant vector would be Rx square plus Ry square. So that would be negative 98.28 plus 21.7. Okay, so this is 100.6. Okay, and the angle will be Ry over Rx, which is 27.12 over 98.28, which is, this is 12.45 north of west. So the magnitude of the resultant vector would be 100.6, and the angle it makes is 12.45 north of west. We can also draw like this. Like this was vector A, this was B, okay. This, okay. And then C, we can find this is the CX and this is CY. Okay. The resultant vector is from tail of A to the tip of B. Okay. So this is the resultant. You can also draw like this. A, and then B, and this is CX. We have, and this is the resultant. Okay. And also do like this is draw vector A, okay, and then add CX to it, okay, and this is vector B, which goes up 50, but C comes down 28, CY comes down 28, and then this is the resultant one. Or we can draw is Rx, uh, this is the resultant vector R. So this is the way we can do, and this angle gives, this is the angle which is 12.45 north of west, and the resultant is 100.6 meters. Okay. I'll see you in the next class. Thanks for joining.